Alright, hey everybody, welcome back. Today we're going to be taking a look at vertex shaders again, and specifically a kaleidoscopic layering effect that will be a good use case for us to just explore vertex shaders a little bit more, and also see how they can interact with the fragment shaders to achieve effects. So this is the scene. This is my kaleidoscopic layering effect with a little bit of post-processing. So here's our entire network. Basically, all of this is post, and I'll include that post in the file for my Patreons. And I think I'm going to do another tutorial about the post processing itself as well. But this tutorial is going to focus just on this component, which is the actual layering that we're applying the post to, as this is the part that uses vertex shaders and is kind of the meat of the effect. So, with that said, I will simply get rid of almost everything here, I guess. Not quite everything. I will keep my in and my out, and then I'll get rid of everything else. Okay, so what we're after is basically a shader that's going to be able to take a bunch of instances and then do something to those instances, in this case rotate them around on top of each other, and then using some sort of mixing algorithm, combine the colors of those images to create that layered kaleidoscopic look. So the first thing we need to do is start with a little instancing network. So I'm going to use a rectangle SOP and then drop down a geo. I will then have a render and a null, which I'll wire into my out. And then I will use a camera. And I'll make sure to set that view to ortho. Now, I'll also get rid of everything on our parent component. So now we can drag and drop this render resolution onto our parent component and get that parameterized. We can then change the size of this rectangle to be me.par.sizex times op. Let's say render1.height over op render1.width. And so now we're going to have an aspect corrected rectangle, which means that we can also set our ortho width to 1 on this perspective camera. And now we have a rectangle that is nicely overlaid. Now we may want to switch up that ortho width later, so I'm going to parameterize it, and I'll clamp the minimum here to something like 0.3. So now we can use this to be able to zoom in and out very nicely. And I actually think we want our max at around 1. So now we can basically just zoom in and out, although you can't see anything happening right now because we don't have a material. So we can drop down a Fong. We can drop our color map on the Fong. Whoops, and then drop the Fong on this geo. We will use an attribute create to create some normals and tangents, and then an ambient light to light up our scene. Now, this is super zoomed in, and by using our ortho width, now we can see that this is indeed pulling us out, and we do have the full image, although it is flipped. So we can use a null, And then we can use a flip. And there we go. And now this, oh, never mind, it wasn't actually flipped. So there we go. So this is our basis. And from here, we can start to use our Vertex Shader. So we will output our shaders from this Fong. We will get these DATs down here so that we can work with them. And then what I'm going to do is use a switch material and then a null material. And then I'll rename this null mat and I'll drop it onto our geo. So now we can move from our material we know is working to this new material that we're working on with ease. All right, so now what we need to do is using our Vertex Shader and our Pixel Shader, but mostly our Vertex Shader, takes some instances that we are about to create and rotate each of the instances a little bit. So maybe we can start by using a parameter, which we can call number of layers. I'll make that an integer and cap it at, I don't know, 12. And then make a default 1 and clamp it at 1 so we don't have any less than 1 layer. Now we can turn on instancing and set it to manual instance length. Drop that number of layers, and then I'll move that up to 12. I will also just increase my render resolution while I'm at it. Cool. So one thing that we will definitely need for us to be able to do this is a rotation matrix, a text file, and this is a rotation matrix that I got from David Braun. And so I'm literally just going to copy and paste it in here. Here is the full text for those of you that want to be able to recreate this exactly. It'll obviously be in my Patreon as well. And then be able to just use this function to then rotate any point by a XYZ rotation value. So we'll go into our GLSL, and I'm just going to drop this as the preprocess directives so that we can then go on using that matrix operator. And now give me 1 second while I close. Let's do like this. And text port and DATs. Okay. So let's start getting into our Vertex Shader. I guess I actually want to edit this in text port. Okay. So if you've watched my Vertex Shader 01 tutorial, this should not be completely new, and you should have a little bit of an understanding of what these functions are and words mean. So I'm not going to go over the absolute basics, but of course I recommend checking out that tutorial if you need a refresher. So We have our S color map sampler, which is great. We need a couple other vectors for us to be able to work. So we'll need u num instances, and we can set this equal to our number of layers. And then we will want to know our u start rotation, and then we'll need a value for u end rotation. And what we'll basically do is use our number instances to figure out what number instance each of our rectangles is, each of our quads, and then rotate that a fraction of the way from our start rotation to our end rotation. So, for example, you can just make this 360, and then in our Vertex Shader, we can amend a little of this. So we will add a line, and that line will be to create a value. So we'll call it PCT, and this is going to be basically our TD instance ID divided by u num instances. And we can just add our uniform float u num instances to our shader. And we'll use this over here so we can see it. And now, if we also grab our uniform form vec3 u start rotation and then u end rotation as two separate vectors, then we can do a float rotation, which will be a mix from our u start rotation, u end rotation, and then we'll use our percent to mix between those things. This should actually be a vec3 though, because each of these is a vec3. So get instance specific value from 0 to 1, calc instance rotation. Now, since our preprocess directives includes this handy function, we can actually just use that. And so what we can do is say, we'll create a new position. So we'll create a variable from SOP attribute P. This is the location of each vertex. So we'll say vec4 and pose is equal to P. And then we can say npose times equals, and here we'll use our rotMatXYZ function, and we can just pass in our rotation XYZ components just like that. Now there's something a little bit wrong, which appears to be on line 29. On line 29. So actually, this should be a vec4, and then I should be using TD deform of P here, and I believe, yeah, that'll get rid of my shoes. So now we have our npose. We can update this down here at npose. Pass new vertex pose. So that's pretty easy. for our vertex shader. Now, if we come over here, change our blend mode to add, and then let me do this. Okay. And I need to switch this switch from index 0 to index 1 so we can actually see our new work. And then I'll move this ortho width a bit out so that we can see kind of the whole view. So now we can see our instances are now rotated just from that little bit. Now you could do this in other ways, of course, but it is, of course, the point of this tutorial to show how to use the Vertex Shader to do it, and it's really easy to do with just a few lines of code in the Vertex Shader. Now, this isn't looking great, and what we can do next is use the Fragment Shader to blend some of this coloring. First, however, I will say make a rotation parameter, which will be float. And then I'm going to change my end rotation to actually be this rotation parameter times 360. And so now we have this draggable, and if I make our number of layers able to go much bigger, we can see that we can now add a ton of layers, and we can rotate these layers more or less arbitrarily or in an animated fashion. So move that back to 1. I'll put our layers back at 12. And now what we can do is edit the pixel shader. So we'll edit these contents in textport. And what we want to do for the pixel shader now is take our instance colors and blend our instance colors based on how many instances we have. So it's kind of like an average of those instances in a way that will help us then have just something that looks visually appealing and not just literally like we're layering this on top of each other. So to do that, we need to give our fragment shader a little bit of knowledge. And the first piece is going to be a uniform. Float unum instances, just like we passed to the vertex shader. And now, what we can do is take a, using this color map color, because this part right here is reading in color from sampler map. So we can take this color, and what we basically need to do is just divide it by the number of instances. So let's try, we don't really want to divide the, well, let's try it. Let's just try color map color divides equals unum instances. And just like that, there is something happening, and it is a little bit different. I will add a transform so we can see it a little bit better. But this is still not perfect. One of the reasons is that the alpha is way too low. So we can add another variable, vec3, and call it final color equals color map color dot RGB. And then we'll get rid of this one for now. We can also get rid of this lighting because we just don't need that. Although I guess I reuse the variable final color here, so I'll rename it to O color instead. Alright, so we can also get rid of this. Final specular undeclared identifier. Get rid of this too. So we don't really need all of that. Don't need this ambient either. Actually, I think that might have been wrong because we're using our ambient light, so I am going to keep that in there. And okay, so now we have our out color. Okay. So we actually can get rid of the ambient lighting if we just set our final color here to our color map color. And then now, what I want to do is define my alpha here. And then after I do this, down here, after we do the dithering, now we want to do our final color divided by equals unum instances. Very good. Now on our shader, we can turn our blending transparency to on. We'll make our destination color 1, which will bring back a little color here. And then we'll turn off depth testing. And then the blend mode should be set to add. Here, here, we will bring our ortho back to about 1. And now we're starting to see some of this interesting effects. We can animate our rotation, change our number of layers, and those are interesting. But this still leaves a little bit to be desired. We're actually done with the Vertex Shader and Fragment Shader, so that was pretty easy. And then all we need to do here is add a Texture SOP. Now, this Texture SOP is going to let us scale our textures, or really scale the texture coordinates that are then looked up from, or change the offset. So both of these are just interesting for adding some visual complexity. So I will say texture scale. I'll parameterize that. Make it a float. And then default it to 1, and then clamp it at like 0.5. 1 maybe. And then I'll drag and drop that onto my texture scale. So now we can do this. And yeah, we'll also do texture offset. And I'll make this an XY. And so now we can also use this to add a little bit more variety. And the reason I made it XY is because you can then change the different components individually or at different speeds and have some just more complex motion going on. I'll set both of these to 0.5 for now, or actually maybe I'll reset all back to 0 for now. And so now we have a setup that is pretty configurable. Will allow us to set these number of layers and rotations, and then will also let us animate things. So we could do like an LFO that has an amplitude of, maybe an amplitude of 5 and an offset of 4. Make the frequency like 0.05, maybe, something like that. And then our texture scale with it. And then I can do another one. I guess I can text scale. Drag and drop. I'll name this ortho, and then this can go from, what is that, 1 to, okay, 0.3 to 1. So 0.3 to 1 has a center of 0.65 and a width of 0.35. And then maybe I'll make the frequency a little bit different. And we'll drag and drop this on. Maybe I want to slow down this LFO a little bit, actually. Cool. Now, of course, you can animate all of these other parameters too. I'm going to leave it here, I think, as, again, the main discussion was a usage of the Vertex Shader. Before I go, I will call out 2 things. One, these buttons that I've been using up here are from my friend Function Store, aka Dan Molnar. Definitely take a look at his Patreon and use these tools if you are interested. They're super, super helpful for workflow. Really great. And point 2 is thank you all to my Patreons. It's really, truly so supportive. It's been able to make my life very different and take some leaps that I probably wouldn't have taken otherwise. So I really appreciate that from everybody that is supporting me. Please give me some feedback if there is anything that I could be doing better or differently. And I will see you all next time. Thank you.